The topic for today's video is atomic structure. The essential questions are: what are the subatomic particles, what are the properties of each particle, and how do you find the number of each subatomic particle from the periodic table? So the atom consists of three main subatomic particles. Hopefully this is a little bit of review. We've got protons, electrons, and neutrons. Quarks can make up protons and neutrons. Okay, so they're even broken down further. The charge of a proton is positive. You can remember that because they both start with a P. Electrons are negative. Neutrons are neutral, which means they have no charge or zero. Okay, the proton has a mass of 1 AMU. It's called an atomic mass unit. Electrons, they do have a mass, but it is super duper small. So when we're doing calculations, just say that it's 0 because it is so small it's really not important to count. Okay, and then neutrons are 1 as well. So an atomic mass unit, it was made out of, based off of carbon-12. A lot of our stuff is based off of carbon because it's a main element that has to do with life. And so they took the mass of carbon and they knew that there were 6 protons and 6 neutrons in there, so there's 12 particles in there. And so then they divided it by 12, and so 1/12 is 1 AMU. And it's just to make it something that we can kind of talk about and grasp, because again, the mass of a proton or a neutron is so small. Okay, so the general structure of the atom, you have the nucleus in the center, and that has protons and neutrons inside. Okay, so that's mostly positive because protons are positive and neutrons are neutral or zeros. So you've got positives and zeros in there. So it's very small. It's dense, means it has a lot of mass in there, and it's positively charged. This outer area is called the electron cloud, and that's obviously where the electrons are. Okay, so the atomic number is the number of protons in the nucleus of the atom. Okay, and the atomic number determines the identity of the atom. If you have an atomic number of 2, that's helium. It has 2 protons in the atom. If you have an atomic number of 6, that's carbon, and it has 6 protons in the nucleus. Okay, for instance, this one has silver. The atomic number is in the left-hand upper top corner, 47. Okay, the mass number is the sum of the protons and the neutrons. So that's going to be a whole number. Okay, so you say it after you say the element. So carbon-12, it has a mass number of 12. In this case, it has 6 protons because it's carbon, and so we subtract, and it also happens to have 6 neutrons. They won't always match, but sometimes they will. Okay, and that's the mass number right there. Okay, this is one way we write it. We put the mass number on top, and we put the atomic number underneath, and they're both to the left of the symbol. Okay, so I know because it's carbon and because the atomic number is 6 that I have 6 protons. My electrons for right now in this unit are always going to match my protons because we have neutral. So 6 protons is 6 electrons, and then 6 neutrons I get from subtracting those two. Okay, so we're going to do some practice with this. First one, we have iron 56. So we look up iron on the periodic table and we find that it's number 26. So for atomic number. So 26 goes on the bottom, 56 goes on the top, and Fe is the symbol for iron. And the reason for that is a lot of these use the Latin names and get the abbreviations from that. Okay, so the protons is equal to the atomic number, so it's 26. The electrons is also equal, so that's 26. And to find the neutrons, we subtract those two numbers, so 56 minus 26 gives us 30. Oops, oxygen came up there. So oxygen 18 is what I would write there. O stands for oxygen, and I write my mass number after that. So my atomic number is the bottom number, so I have 8 and 8 protons. Electrons will be the same, so it's 8. Then I'm going to subtract those two, so I get 10 neutrons. Okay, this next one tells me what the protons are, which is 55, so I need to look that up. Okay, and that's cesium. And to get the 137, I just add my protons and neutrons. So I took 55 plus 82, and that gave me that 137. Okay, I'm not looking on the periodic table for the mass number because it's a decimal number, and I'll explain that a little bit later. Okay, so I take I write my symbol. So 137 goes on the top, 55 goes underneath, and my symbol for cesium is CS. Okay, it is important when you write the symbols, if they have 2 letters, The first one is uppercase, but the second one is lowercase. Okay, then my protons are 55, my electrons have to match. All right, this next one, I look up on the periodic table number 19, which is K, and I find that it's called potassium, and then I put my mass number afterwards, -42. Okay, my protons match my atomic number, so that's 19. My electrons also match at 19, and I'm going to subtract 42 minus 19 to get my neutrons, and that gives me 23. Okay, this next one gives me protons and neutrons. So I look up number 82, and then I add them together to get the mass. So 82 is lead, and then I take 82 plus 128, and that gives me 210 for my mass number. Okay, my protons and electrons match, so it's also 82, and then I can draw my symbol. 82 goes on the bottom, 210 goes on top, and Pb is the symbol for lead. And again, that's because of the Latin name for lead. That's why it's Pb instead of something more closely related to lead. All right, carbon 14, this is the last one. So I look up carbon, and it is number 6 on the periodic table. So I have 14 on top, 6 on the bottom, and then my C for carbon. My protons will match that bottom number, so that's 6. My electrons match as well. And then I subtract those two numbers, 14 minus 6, and that gives 8 neutrons. And so that is how we find protons, electrons, and neutrons in using our periodic table and our mass numbers.